Assalamualaikum dan salam sejahtera. So now I would like to share with you exercise 5.3, number 1. Okay, so in this exercise, we would like to find relationship between the percentage of hydrocarbons that are present in the main condenser of the distillation unit and the percentage of purity of oxygen produced. Okay. So we will use two methods to test the linearity. Okay, before that, we need to identify in part A the independent and dependent variables. Yeah. So from this we can see that a hydrocarbon is the input. Yeah. That means this is the independent variable. You can put certain. You can decide on percentage of hydrocarbon that you want to put in the distillation or main condenser of the distillation units. Yeah, so it is the input. So you decide on how many percentage of hydrocarbons. Whereas oxygen purity is the percentage of purity of oxygen produced. So this will be the output. Yeah, the output. Yeah. So that means the dependent variable. So this value depend on the how much you put the hydrocarbons. So this one will be Y. Yeah, input output. So X hydrocarbons is the independent variable, whereas oxygen purity in percentage is the dependent variable. So you can you can answer that part A. Okay, in part B, you will like to test the linearity between X and Y. That means the relationship between X and Y for at 95% confidence interval using t-test and ANOVA. Okay, so there are two methods. Yeah, so the conclusion will be the same. Either we use t-test or ANOVA. Okay. So for t-test, first of all, you need to find all the sum because you need to identify or determine the regression line. Yeah, first of all. Okay, so you need to find, okay, I give you the data and you can check this later. Sum of y is 734.77. Okay, sum of y squared 67549.5715. So make sure 4 decimal places. Sum of x equal to 9.37. Sum of x squared equal to 11.2581. Okay, and sum of xy equal to 864.7682. Okay, so this is the summation that we have. And then from there, you use the formula, you can find SXX equal to 0.2835. Yeah. And then you have SYY equal to 63.7024. Okay, then we have SXY equal to 4.1688. And you can also calculate the mean value of X, which is 1.1713, and the mean of Y, okay, equal to 91.8463. Okay, so you need this value to calculate for beta node later on, yeah, and you need this value to calculate for beta 1, yeah. Okay, so and then yeah, from this you can determine the best fit regression, the regression line. So the estimated regression line. Okay, similar method before. So you have beta node 7.6226 plus 14.7048 times x. Yeah, so this is beta 1 and this is beta node. Okay. Okay, similar method, yeah. And then, okay, after that, you can find the mean residual if you want. Okay, before that, okay. Okay, step 1 will be, once you have all the value, will be to state the hypothesis. So H naught, yeah, you can write beta 1 equal to 0, yeah. beta 1 not equal to 0. Okay, or you can write inward. That means the slope of regression line is 0. The slope of regression line is not equal to 0. Okay, step number 2 will be the test statistic. Yeah, t-test. Okay, which is equal to 14.7048. Yeah, which is beta 1. Yeah, minus 0. Yeah, divide by the standard error of beta 1, which is equal to, so you can write 0.4002. Yeah, I have calculated that before, so you can double check. 0.2835. Okay, so you take the square root of that, so you will get 12.3765. Okay, so that is a t-test. Okay, and then step 3. Okay, you need to check the critical value. So in this case, our critical value is, so alpha is 5%. So since this is 0.5%, since this is two tails, so you are looking at t 0.025. Yeah, so plus minus. Yeah, degrees of freedom will be, how many n we have in this problem? Okay, we have 4, 6, 8. Yeah, so 8 minus 2 will be 6. Yeah, 6. If you look up in the statistical table, you will have plus minus 2.4469. Okay, and then we compare. Okay, so if I can draw this, yeah, to help you visualize. Yeah, sorry. Yes, okay, help you visualize. So we have this one minus t 0.0256. Yeah, so this is t 0.0256, okay, which is 2.4469. This one equal to negative 2.4469. Okay, the value that we calculate is this one, okay, which is in the rejection region, yeah, in the shaded region. So this is t-test. Okay, so this diagram just help you to visualize. Okay, so but you still have to rewrite it. So t-test is larger than t 0.0256, which is 2.4469. Okay, therefore we reject H naught. Okay, and then we can conclude that at, yeah, alpha 0.05, yes, significance level, yeah, that means there is, yeah, linear relationship yeah, between percentage of hydrocarbon and percentage of oxygen produced, purity produced. Okay, so that is using t-test, yeah, t-test method. Yeah, testing for linearity. Okay, so next we are going to look at on how to use ANOVA table. Yeah, so similarly, step 1 will be, okay, we have all the value just now. So we have step 1 to state the hypothesis. Okay, okay, before that, okay, before that, so this one is using, okay, ANOVA table. Yeah, ANOVA table to test for linearity. Okay, so step 1, H naught will be beta 1 equal to 0, H1 not beta 1 not equal to 0. Please take note that for the hypothesis we use parameter. Yeah, that is why there is no hat there. Yeah. Okay, step number 2, we need to construct the ANOVA table. Yeah. So we have source of variation. Okay. And then we have sum square. We have degrees of freedom. And then we have mean square. And then we have F test. Okay. So first for regression. Okay. And then residual. And then we have total. Okay. So for the total SYY, so 0.3388, yeah, 0.388. And then for the regression, you have, yeah, which is SXY times beta 1, yeah, so 0.32, so you can check this, 3253. So the balance between that will be 0.0135. Okay. Now for the degrees of freedom, there are 8 data. So 8 minus 1 is 7. So this is always 1. Okay, 7 minus 1 is 6. Okay, for mean square, so you just divide sum square divided by degrees of freedom. So you have 0.3253. Yeah. And then divide by 6, yeah, sum square for the residual divide by 6, so you have 0.0023. And then to find F test, you simply divide 0.3253 divide by 0.0023, yeah, which will give you 141.4348. Okay. So this is what you will get, and then we will compare this value, yeah, for the critical value. So F critical value will be, this is at 5%, so 0.05, yeah, 16, yeah, so 16. So which is equal to 5.98. This is from table, 5.9874. Okay, so and then we will compare this with the F test. Yeah, so from this we can say that F test is greater than F 0.0516. Yeah, so if you want to draw, so similar lah, like before. So this is our F critical, F alpha 1 n minus 2. So so this is F test, yeah, our F test. So it is in the rejection region. So reject H naught, yeah, since the test statistic value is much larger than the value from the statistical table or the critical value, therefore we reject H naught. Then you can conclude that similar conclusion, yeah, L alpha 0.05. Yeah, you can write the similar conclusion. That means there is a linear relationship between the percentage of hydrocarbon and the percentage of oxygen purity produced. Okay, so that's all for 5.3. Okay, for the second exercise, you can try on your own.